Okay, let us discuss this problem. This is an easy problem, you can do this one. Again, writing mechanism, this related. So we have a cyclohexanone. If this molecule is treated with this molecule, this molecule contains OH as well as CN both. Now this kind of thing is called cyanohydrin. Hydroxy group and cyano group, so this is the cyanohydrin. So this is the cyanohydrin. If I react in basic medium with OH minus, this gives the following product. You will get acetone CH3CH3 and you will get one cyanohydrin. So you have to propose the mechanism. Now you see what you have done. You have removed one CN from, so there is CH3 but no CN here. You have only O. So this means you have to remove CN, one hint. Now you see, if you see this molecule, there is a CN that is attached. Initially there is no CN. Here now you have a CN that is attached. The another hint is you have to attack one CN here. So on this you have to attack CN minus, then you can get something. So now this is the enough hint. You have the medium is basic medium. What this OH minus will do? OH minus can take a proton. Now things are very simple. You have to decide the mechanism for this given reaction. You have to propose the mechanism. You can do this one. Let us take 1 minute time. Let us see how many of you are able to do this one. So timer starts now. Okay, let us do. So let us see the solution. How can we do? So we have, so I have here CH3. So let us remove this one. So we have CH3CO and CH3. So this molecule, basically there is a CN here, no CH3. So I have CN here. Now this base can take one proton from here. Now this becomes acidic hydrogen. If this base takes one proton and this bond goes here, so oxygen will have a negative charge. So you see here, now oxygen contains a negative charge. Now this step is a reversible step. So acid base reaction, this step is a reversible step. Now at the same time oxygen has a negative charge. This electron pushes the Cn minus group, because Cn minus is a good leaving group. So oxygen negative charge comes here, Cn is pushed off. So if you push this Cn, you will have CH3CO CH3, because CO double bond you will have. Here you will have a double bond. Now if you are pushing this one, you will have CH3CO CH3, the acetone, and you will have a Cn minus. So plus Cn minus. Let me write Cn minus here itself. So you will have a Cn minus. Now this Cn minus you can use in the next step. Cn minus can attack on this here. Cn minus can attack, this goes off. So this is again equilibrium reaction. You will have CnO minus. If you treat with this H plus, you will have OHCN. So simple. Now again this is a equilibrium. So each step is reversible. So you have to see each step are basically reversible. Now this reaction is favored due to some reason. First is Cn minus is a good leaving group, and Cn minus also acting as a good nucleophile, That's why this reaction is happening. So if you know something like benzoene condensation or something, I think so, benzoene condensation, there is a reaction something like benzoene condensation. You have the same kind of thing in Cn minus act as a leaving group as well as nucleophile. Now any other thing, this reaction is done in basic medium. So medium is basic. So you can see in this case medium is basic. So you can copy this solution. I think you are able to understand. So this is from aldehyde ketone. So this is something related to formation of cyanohydrin. You have a cyano group, you have a hydroxy group. So this is a cyano group, this is a hydroxy group. So this is something related to formation of cyanohydrin. Okay, we'll discuss the next problem.